let's get to it. So what is the sine rule? The sine rule states that if A, B, and C are lengths of the side of a triangle, and A, B, and C are the angles in the triangle, with A opposite A. So we have, if I have the angle A here, opposite of it is the side A. If I have the angle B, opposite of it is the side B. And if I have the angle C, opposite is the side C. Then I can say that A over sine the angle A is equal to B over sine the angle B is equal to C over sine the angle C, which when inverted, so if we invert it, or if when inverted, we'll also get, which is the same thing, sine A, sine the angle A over A, which is equal to sine B over B, which is equal to sine C over C. The sine rule can be used for any triangle, even right angle triangle. Please, people. I'm going to do some videos debunking this, because I know some teachers tell students that you only use the sine rules for non-right angle triangles. No, it's used for any triangle, all right, where a side and its opposite angle are known. So let's get into the proof right now. Now let's get to the point. Now we're going to prove the sine rule. Now, in any proof that we're doing, we need to work from what we know. So what do we know already? What are we coming with? What's our previous knowledge done? We know that sine the angle is equal to the opposite over the hypotenuse. So how we talk about opposite and hypotenuse, and we just have one blank triangle here. Let's go ahead and label our triangle. Now if we have our triangle ABC, A, B, C, and we were to label our sides, and you know how we label the sides. So if this is my angle A, the side corresponding to angle A is known as the side A. If here is my angle C, the side corresponding, or the opposite side to the angle C, is going to be C. And if here is my angle B, the side opposite to the angle B is known as the side B. And we use common letters to identify or to denote the length of the sides, and we use capital letters for the angles. Now, our normal triangle here, how do we work from what we know? Now, what we know how to deal with right angle triangles. Now, suppose I was to draw a line from A to BC. Alright? And let's call that line H. So we call it H. And right where the intersection is, let's call it D. So, look more familiar. Now we have two right angle triangles. So we have A, B, D, and we have A, C, D. And considering the angle that we're given the angle B, and we're given the angle C, let's use those angles to find the perpendicular height H. So let us look at it. So considering triangle, so using triangle, and you know my handwriting is very beautiful, A, B, D, we can see that sine B is equal to the opposite, which is our H, over the hypotenuse, which is C. Now we want to find H, so we know that H is equal to C sine B. And that gives us H, and that's our first equation. Now we want to find H in the triangle ACD. So using triangle, you know my writing beautiful, ACD, we know that sine C and sine C, which is opposite again, over the hypotenuse, the opposite, which is our h, and our hypotenuse is b. Now to find h, we know that h is going to be b sine c. And that gives us h. Now, we can call this equation 2. Now, looking at equation 1 and equation 2, we realize that we have what? We have 2h. So we can easily say now, h is equal to h. Don't, because we have h and h equal to h. So thus, since h is equal to h, we know that c sine b is equal to b sine c. Now, let's go ahead and let's form, because we are right here at the crook of it. Now, we're working from what we know, using that, and we want to get what? We want to get a over sine a is equal to b over sine b is equal to c over sine c. So we're going to rearrange this now to form any of these two pairs. So let's go ahead and rearrange. Let me just rewrite it. So we have c sine b, capital B, is equal to b sine c. Alright, now from here we can do two things. I'm going to work it both ways, and it's up to your algebraic manipulation from here. So here we want to put it in this form. So we can divide both sides. Let me change the ink, color out my pen. We can divide both sides by sine b sine c. So the sine b sine c. We can. So then let's go ahead and do that. So we have sine b into sine b. So we're left with c over sine c. And we cancel sine c, cancel sine c. So we're left with b over sine b. Or what we could have done when we have c sine b is equal to b sine c, we could have divided both sides of the equation by bc. So if I divide here by bc, the c cancel the c, so I'm left with sine b over b, which is equal, and over here if I cancel the b's, I'm left with sine c over c, which is the same thing, just the inverted form. So inverted, we would have b over sine b is equal to c over sine c. And we have proven the sine rule. Now somebody might be asking, so where the a there? I don't see the a, but we could find the a by, if I were to put on a next, suppose I were to draw in a next line. So if I were to draw a perpendicular line from C, let me fix it, it's not so neat. Ooh, did I do that? Alright, let me try to draw it a little bit neater, still not neat. But if I drew my perpendicular line from C to the line AB, then I'll now have the angle A and be able to find sine A. But because we know that by algebraic symmetry, we can simply just deduce that A over sine A is equal to C over sine C, which is equal to B over sine B. And no matter what way you want to put these three ratios, they are equal to each other nonetheless. There is another way that we could have worked this. Can you guess that other way? Write it in the comment section. Alright, one other way that we could use and prove the sine rule is to use the formula for the area to find the area of a non-right angle triangle. You know that formula would be area is equal to half AB sine C. And we know that these are the sides surrounding the angle C. So if I had my triangle A, B, C, we know here would be the angle C, so that would be the sine C. Here would be A, here would be B. I don't know why I'm labeling them twice. Maybe just feel extra. Alright. And then we know we have our opposite sides. So if here is A, then the side here would be A. If here is C, then the side here is C. If here is B, then the side here is B. Now, we know how to use this formula, right? So if I'm going to use sine C, I have to use the two sides that surround sine C. So the two legs for sine C would be A and B. So therefore the area would be half AB sine C. And we can know that area is equal to area. So hence, let us look at another angle. What are we looking at? Angle B. Looking at angle B. Now, what side surrounds angle B? So, focusing on B, we have C and we have A. So, we can have half AC sine B. Now, we're going to manipulate this formula now to find what we want to find, which is either A over sine A is equal to B over sine B. And these are capital letters. I don't know why I keep writing common. C over sine C. Alright, so with our algebraic manipulation, we can multiply both sides by 2. So if we multiply both sides by 2, then we're just left with AB sine C is equal to AC sine B. Now, we could just do it fast here, so we could just simply manipulate, so divide both sides by either AB or AC or sine C sine B. It depends on your algebraic manipulation. So I'm going to divide both sides by sine C sine B. Sine C sine B. And it's an equation. So whatever is done on one side has to be done on the other side. So we know that the sine C here we cancel sine C. And we know that sine B here we cancel sine B here. So we're left with AB over sine B, which is equal to AC over sine C. Now realize that there's an A hindering us because we're almost there. So how do we get rid of the A on both sides? So we're going to multiply both sides by, let me see if we can change the color to highlight this one. So we're going to multiply both sides by 1 over A. So multiply both sides by 1 over A. And remember, this is algebraic manipulation, so you can manipulate the algebra how you are comfortable manipulating it. So we have B over sine B is equal to C over sine C. And ta-da! Proven. So we use the area of a non-right angle triangle, which is half AB sine C, to find also, or not to find also, why my grammar is so terrible, but just to find or just to prove the sine rule or the law of sine. And as we said, if you were to take sine A, you could go ahead and equate it to say, okay, A, and then you have CB using the legs C and B, sine A. You could manipulate it that way. So you could choose any two angles and work it that way. Or you could just equal all three area to area to area and get the same thing. So it's just It's just your manipulation of the formula. Alright, so thank you guys for watching. Any comments? Any questions? Put them in the comment section and give me your recommendation. Thank you. See you next time.